Alright guys, so welcome back to another tutorial. This one is also for a mobile game. This one is going to be for a really nice, really polished mobile game that we're going to make from scratch. We're not going to be using 3ds Max, we're not going to be using any 3D software. We're going to be using primitive, but they're going to look good. So, right guys, so let's get started. In this episode, like you saw in the preview, we are going to make a tower. Now, we could go ahead and just create that cube model, that tower cube model inside of 3ds Max and then import it in here. But what I felt like doing is actually, since I don't want to use 3ds Max at all, since that would cause friction with people who don't have that software or any 3D software really, we are going to create our mesh inside the code. And it's also a good opportunity to learn how to actually create mesh directly from code. So guys, we are going to go ahead and create the most important script of our old game. Let's go ahead and create a new C# script, and we're going to call it the tower. Now the tower is going to be the script for the tower, and the reason it is so much important right now, it is because we're going to be seeing this in every single scene. And I've made a little concept. I didn't really make any concept, but usually when I start making a game, I have this Photoshop sheet where I can just write stuff on it, and that's pretty much what I've did here. So for my menu, I'd like to have like this amount of stuff in it. I've written everything down, and also a nice preview image that is going to give me a feel based on my memories of what kind of menu I'm trying to achieve. So in this case, whenever we launch the menu, I'd like to load the previous session, so it is seamless, nobody sees it. There's no load button, it just happens when the game loads. So it is going to load your previous session, all your stats from your tower, and on the cloud. So we're going to be pulling that from the internet, and we also have an option for local save as well. I've written that as a maybe, but we're most likely going to have it for people who don't have internet on their phone, or 3G when they're in the bus or something. Right. And what else do we want to have in that menu? I'd like to have my camera that moves around the tower, so whenever we open up the game, I'd like to have some kind of cinematic where it's just a camera rotating around our turret, and if we tap once, we actually get the nice pop-up. So in this case, this is the reference image I use, so we get the splash image with the text of the game, and also the press any button to start. Right. Then if we tap once more, we start the game. We're also going to have some side buttons, which is going to allow us to wipe our save, the achievements, and a leaderboard. So that's the goal for my menu. Of course, we're not going to be doing all of this today. Today we're going to simply create, well, at least start creating our turret script. Great. So we're not going to be doing the gameplay just yet. We're going to start by just displaying that turret and also changing the size depending on few properties we have. Okay, so back in the engine now. I am going to go under Window, Lighting, turn off that default skybox. I really don't like this one. And a small tip I'm going to give you guys. Since I want to make this a phone portrait game, so I want it to be like this, so I wanted the screen to be tall, not wide. I went ahead and I've created inside my game window, so this window over here, the one that you can dock pretty much anywhere, I went ahead and I created myself a phone HD resolution for portrait. Now this one is 640 by 960. In case you'd like to have this for the widescreen, so in case you're deciding to just forget about what I'm doing and you're just going to do it in widescreen, then you can go ahead and put it under 920 640, which is pretty much, I think, a really decent resolution for that. I'm not sure it's the exact same one. Well, you can't really be sure depending on which device you're using because all devices have different screen size, but it is fairly good for developing on widescreen game. Right, so I'm going to go back under Portrait, and this is going to be my preview. Right. So enough playing around with the UI, let's go ahead and open up the tower script inside of Unity. Okay. So this is our tower script. Now this one is going to be in every single map, so I just said in the menu I'd like to have a camera rotating around this tower, so it is going to be there. The first thing I will do is declare myself a private void start, and inside of that start I will say don't destroy unload game object. Okay, so whenever we boot that very scene, the scene that contains the tower, we are going to tell Unity to never actually destroy the game object we have right now. So it is never going to destroy the tower at all. Even if you're swapping scene, even if you're... Well, I mean, the only way you could destroy this is by calling the actual destroy function, and then you give in game object. But of course, we are not going to be doing that because we want it to be there all the time. Right. And I'd also like to be able to access this script from pretty much anywhere because I'm going to be using it constantly. So I will go ahead and create a public static the tower, which is our type, instance. Now you can actually change that name. I just felt like it was a good name, so I'm going to leave it there, right? So whenever we need this tower from anywhere in the script, we're going to be saying the tower.instance, then we've got access to pretty much everything that is public in here. Okay, so that's a nice beginning. Whenever we start, we'd like to say instance is equal to this, so we don't get a no reference error. That'd be a really good start. And then what else could we be doing? We could actually create a mesh, because what's going to happen now is we're going to have this on a empty game object, and we need to actually create our mesh. So let me just boot that real quick. Before we do any more code, what I will be doing is actually creating a new empty game object. So go over here, game object, create empty, and let's name this the tower. Alright guys, and then I will move this to the origin of the world because I want everything to be centered around the origin of the world. So the turret is going to be there. The tower, the turret, I'm going to be using those two words all the time, but you know what I mean, the central piece of our game, right? So here it is. We are going to save it under a prefab because I don't want to lose it. Now, I've made a small mistake. Let me just correct that real quick. Create a new folder that I call prefabs. And I'll also create another one for script. And also another one for scenes. Since I'm here, why not? Okay. So the tower goes under scripts. Scenes, it's not there yet. And then the tower over here, this object, you're pretty much going to have selected from the hierarchy because right now you don't see it in the scene like this and you can't really select it. So select it from here, drag and drop this right inside of your prefab folder. Now this way we can actually instantiate it from anywhere, but we're never actually going to reinstantiate it. We're just going to leave it in this scene and then boot the rest of our game, right? So like you probably guess, under the tower, we are going to drag and drop the tower script like this, and then hit apply. We should now be ready to go for this turret to actually build itself. But before that, we are going to save the scene. So Control S, and we are going to save this. Now, I won't explain the concept of this just yet, but just tag along, do what I say, and we are going to explain this later on when it comes in handy. This is going to be the preloader. And I'll just give you a glimpse real quick. Since we've said to our object, don't destroy on load, whoops. We've said to our turret, don't destroy yourself on load. That means if we recreate a new, not if we recreate, but if we go back to say the menu scene, just assume that the tower is inside the menu scene. Now if we enter the menu scene for the first time, we're going to have our turret just there, right? Then we go back, we don't go back, we actually go to the game scene. Our turret is still there because it has not been destroyed on load. But say we go from the game scene back to the menu, then our turret is still there, still following us, but now the menu scene also has another turret as well, so we're now stuck with 2 of those. And then next time that would be 3, and then so on. So we definitely don't want to load a scene that contains this object. Now this is the concept of the preloader. We're only going to cross the scene once. At the very beginning of our game, that's going to launch. We don't even need a camera in there. We don't even need a light in there. We don't need any of those. We only need stuff that is going to persist through scenes. So in this case, the tower is going to stay there, and we're going to load at the beginning. We're also going to have a function, not a function, but we're going to have some code running, so whenever we're done loading everything we need to load, we're going to move on to the actual menu scene, and then the game starts, right? So let's go back. I went sideways a little bit. We're going to go back in the code. Our goal right now is to actually create a mesh. Now, how do we do this exactly? We do this by creating an array of vector3. And I feel like making a new function for that, so let's actually make this very clean, right? So private void create tower mesh. And we're gonna call it from here. Now we don't need the comment because this is quite obvious title. And here is what is going to happen. We are going to start by declaring a float that we're going to set on 0.5. That is going to be the actual size, the actual radius of my cube. I can't use radius because that's a cube, but just imagine w times 2 would equal to the length of my cube. Okay, that was a little bit weird, but don't worry about that. Then after that, what we need to actually say when we try to create a new mesh from code is we gotta give it vertices, and those are expressed as vector3 in Unity. So we're gonna say vector3 array vert is equal to a new array of vector3, and then we are going to define all of them in one go. So bear with me, this one is a lot of copy paste, and I've got it written on the other screen because it is quite a pain to write. We're going to start by saying, well, it's going to be, well, a cube has 8 vertices, so it's going to be 8 different vectors. The first one is going to be minus w, 0, and minus w, like this. I'm not going to be using my w float right here. Actually, I will for the height, but I want to make sure that the pivot point of this is on the floor, is below the tower. And that is why I put 0 and not minus w here. Let's proceed. A new vector3, w 0 minus w. New vector3, w 0 w. And a new vector3 minus w 0, oops, and then w. So now we've done all the 4 vertices that are at the bottom of the cube. Next are the one up top, so we do the exact same thing actually. So just copy this. Let me just make sure everything works on my other screen. Yep, so let's just copy this, and instead of writing 0, we're going to type in w times 2. Like so. Okay. So we've got our 8 vertices. Now what we need to do is declare the faces, because only having vertices is not going to actually give you an object. You need to actually declare which faces are where. And those are done by specifying 3 ints. So the 3 ints will actually point toward those vector3. So say we're saying a new face 0, 1, 2, that would be this vector3 with this vector3 with this one. And it would actually create a triangle, which is how it is made. By the way, since these are arrays that we declare on the fly, I know the way I've written it, it doesn't look like it, but you gotta be putting the semicolon at the very end here. Don't forget about this one. Okay, next thing actually, let's do a int array, and those are the triangle, the one I was just talking about. So we do the exact same thing here. Now I've got this written on the other screen because it took me a little while to figure them out. But if we use this, if you have the exact same thing up here, then you're gonna do the exact same thing that I do down there. So 0, 4, 1, then we go for 5, 1, that would be the front face. After that, 1, 5, 2, that is the right face, and this is included in the right face. So 5, 6, 2. Next one would be 2, 6, 3. That's the back. And then 6, 7, 3. Also for the back, 3, 7, 0. That's for the left. Oops. And 7, 4, 0. Also for the left. And then finally, 4, 7, 5. That's for the top side. And 7, 6, 5. Okay. Don't forget the semicolon on the end. And these are my faces. And of course, there is 2 pair of triangles for one face because, you know, a quad is made out of 2 triangles. So we've got the vertex array, we've got the triangle array. Now all we need is an actual mesh. Let's declare it right here. Mesh M is equal to a new mesh like this. Then we're going to say m.vertice is equal to verts, which is our own array. Then m.triangle is equal to tri, our own array as well. And when we're actually done with these two, we need to recalculate bounds and normals, but there's like easy function that you can simply use like this, and it's going to do the whole job. Okay, so now let's have a look at what happens. We have the tower has our script on it. We press play. Nothing happened, and that is quite normal because we don't have any ways to actually first store that mesh. We simply create it in memory right here. It doesn't do anything, it's there, but we never use it. And then we have no way to actually render this. So we need to have something that stores the mesh and then something that renders it. And that is where the GameObject.add component, the mesh filter component comes in, like this. But now this mesh filter by himself is nothing. We're going to be telling him what mesh he's going to be using. So dot mesh is equal to m, our own mesh that we just made. Right, let's proceed. So GameObject.add component, mesh renderer, and this one needs a material, but we don't have any material right now. So let's just make sure we put a mesh renderer like this for now. Let's press play and have a look. Hopefully everything is fine. And if we take a look here, we click on it, we can't really see it. Let me put that on a wireframe. Okay. So we got some nice faces over here. Nothing seems broken, and it's a nice cube. But we never actually did the bottom face, which is, that's fine because we're never actually going to see it. Okay. I'm also going to add a new folder down here. And by mistake, I keep creating those JavaScript files. Okay, so new folder. This is the artwork folder. I'm getting a little bit used to the way we're making projects now, but that's fine. So inside the artwork folder, I'll declare a tower mat, which is going to be the material for that tower, and I'll make sure it is a public field. So public material tower mat, like so. And we're going to come back to our code where we said we're going to add a new mesh renderer. Then we're going to say dot material. The material of that mesh renderer is going to be tower mat. Alright. So now make sure you actually do this. This is where a lot of people forget. We just made this material public. We need to assign it right here. So drag and drop your tower material right in there. Okay. And if we press play, we should get this kind of result. So we actually see our turret. Now it doesn't look like a turret just yet, but eventually it will, believe me. We've made a mesh. That's fine. We can now collapse that. Now the plan for this game is I'd like to have my tower change depending on what stat it has. So say the tower has more range now. I'd like it to be taller because, a taller tower can see further, I guess. Something of the sort, So you see that the stats of the tower is going to affect its size, its position, why not, its color. We can do all that kind of stuff, but first, we actually need those stats. And since I plan on having a lot of stats, so not only like say damage, range, speed, but other things such as health regen, a lot of stats. So basically, what I'm going to do is actually declare a enum up here. So public enumeration stat index, because I'm going to be using this as a indexer, Or you know what? Let's actually just write it like that, so stat. And let's start with the easiest one. So damage is equal to 0. And then range, we don't have to say is equal to 1. It's going to deduce that by itself. So damage, range, speed, and then once we need to add more, we can actually just do comma and then say hit point. Something like that, right? And I'm actually thinking about this, and this is going to be the stat levels, I guess. Okay, well, we're gonna see that a little bit later on, but right now we have our stat enumeration, but we don't have any ways to actually know which level is our turret in every single one of those stats. So what I will do is over here on top of pretty much everything, so I'm going to just push these value down, and over here I'm going to say these are the constants. Let's start with the global ones, right? So these are going to be globals that are going to pretty much, constant, that are going to stay the same for the whole duration of the game. So nothing can actually change those, but they're going to be so close at the top of our script that we can actually change them for a balancing purpose. So the first one being, let's start with a private const float base tower height. And I'll just put that on 1.5. So whenever the game starts, if your range level in your turret is at 1, so you have a fresh, really fresh game, then I'd like the tower to be at least 1.5. And that's pretty much how I write all my constants, so all caps with underscore. Now you don't have to do this, but that's just how I do it. So okay. And for now, that's the only global constant we need for this episode at least. Then after that, I'm going to add stat-specific constants. So say just for range, private const int, not int, let's do a float again. So height gain, or you know what, range height gain. So every time we get a new level in the range stat, I'd like to gain say 0.05 in height. So let's say we start at level 1, our turret is actually going to be 1.55, so 155 in a float. It's not going to be at 1.5 because we need to also increment the range height gain, so that's going to be say the range level times this, and that's how our turret is going to be. Right, so say we have a range level of 10, then our turret height would be 2, because we got this times 10, which is 0.5, and then 1.5 plus 0.5 is equal to 2. Okay, enough basic maths. We are going to create, just below that, I'll go ahead and create a public int array that I'll just call tower stats. So this is where we're going to store pretty much everything, and I'll be putting it in a set get because we'll probably want to be able to access it from outside as well. So not only the turret is going to use this, I believe so far. I haven't really done the whole design, but it is going to tilt toward this way, I think. Okay, so we've got the create tower mesh function. Just below that, let's create a private void rescale tower. And inside of the rescale tower, we are going to do, let's start with a vector3, new scale is equal to vector3.0. Now as for the x, so new scale.x, what could be affecting the size in x? I'm thinking about hit points. So the more hit point you have, the bigger the turret is going to be. Yeah, that could actually work. So let's go back up here and declare a hit point section. We're going to do private const float hit point width dth gain, and let's not do a lot for this one, so maybe 0.025. Right, and the base width, so private const float base tower width dth is 1. Okay, for x is going to be x is equal to base tower width plus tower stats at the index stat dot, let's do hit point times hit point with gain, like this. So that's going to be our x. Our z is pretty much going to be the same exact thing. So new scale dot z is equal to new scale dot x, because it's going to be resizing in the same way on the x and z axis. And by the way, since we're using a enum here, we're going to be casting this as a int, like so. And finally, new scale dot y is equal to base tower height plus tower stats at the index int stat dot range times range height gain, like this. Right. So everything is done here. We've calculated our new scale. Then we're gonna say transform dot local scale is equal to new scale. Oops, new scale, like this. Alright, let's actually try this out in the start. So in the start, we're going to create a new tower mesh and then rescale our tower. And we're going to have an error. I'm just looking really quickly, since there is no stats. So just for the sake of it, let me just quickly make a new, we're going to be removing this by the way, but say tower stats is equal to a new int array, and we're going to say it's level 1 in every single stat, so like this. Right. Let's press play. And here we go. We actually have a scale 1.025, so he's level 1 in hit point. And he's also level 1 in range, as you can tell. Alright guys, so that's going to be the first episode. That's going to be the end. We covered a little bit of stuff. The result isn't great. The result we see on the screen isn't great for all the time we've put, but we've got a really nice base that we can now build on. So guys, thanks a lot for watching. If you think that this video was helpful to you, or you enjoyed it, please leave me a like. Really appreciate that. If you have any comment or question, you can leave them in the comment section below. And also subscribe for more tutorials like these. Alright, so thanks a lot for watching again, and I'll be seeing you in the next one.